All right, hello, hello. Make sure my mic is working, make sure my video is working, pop that on. Cool. Let me get the icons I need, that guy, and then set up my desktop. Share my desktop real quick here. So what are we talking about today? We're gonna be talking about what exactly is a SQL database, right? What is this thing? Kind of how does it work? What are we using it for? Kind of what is its general purpose? Like, why should we be concerned with a SQL database? And what's the big deal? All right. Cool. So what I'm going to do here is I'm going to make a new folder on my desktop. I'm going to call this Database Workshop. I'm going to put a couple things in here. Right? I'm going to throw a Chinook sample database in here. And that's the one I'm going to be working with. Right? The Chinook.db file. Right? Make sure you don't have the zip file. Right? SQLECTRON will pretend like it's going to open up the zip file, but it will not. Right? Actually, I'm going to do that real quick. I'm going to make this in a zip folder. I'm going to open up both of these and show you what's going to happen. Right? I can almost guarantee you that anytime you are opening up SQLECTRON and it sits there and hangs forever, you're probably trying to open up the zip file because it'll let you do it. It just won't work. So while that's doing that, I'm gonna chew on a cough drop so that I don't sound like the plague. All right, I'm gonna get rid of these guys real quick because I don't need their connections anymore. Yes, boom. Yes, all right. So I'm gonna make a new database connection. I'm gonna call this Chinook bad. Complete Chinook zip. This is gonna be a SQLite file. And I'm gonna open up from my desktop my, what does I call this? Database workshop. Yeah, there we go. I'm gonna open up this Chinook zip file. Right? If I hit test, it's like, oh yeah, sure. Everything is groovy. But as soon as I try to connect to this, it's just going to load. And it's going to load forever. Right? It's going to say it's loading a list of tables, and it's just not going to do anything. Right? So what I need to do is either, if it's hung, I need to close this, or I can tell it to stop. I'm going to make a new connection. I'm going to call this Chinook.db. It's going to be SQLite. Instead of the zip file, I'm going to open up the Chinook DB. I'm going to test this one as well, and it'll say it's successful. If I save this, right, I can see that when I press this, when it connects, and it connects immediately. Right? Where my other one, my zip file connects and hangs, because it doesn't know how to read that zip file. But my database file, oh, it knows how to read that. Right? So I guess what is a SQL database? Right? A SQL database is a collection of rows and columns grouped into tables. Right? If you've ever worked with Excel or used Microsoft Excel, it's kind of like that, right? You can kind of picture this as a database. I have columns that go across and they go downwards. So columns go downwards. I have rows that go across the page, right? So say if I had, I'm going to give these columns names, name, nickname. I'm going to have 3 columns. Make this bigger. Name, nickname, and awesomeness. I'm going to rename this worksheet to people. So I can imagine this is my people table with 3 columns, name, nickname, and awesomeness. Right? Name is Ammon. Nickname is, I don't know, I've never really had too much of a nickname. Name is Cool Guy. Awesomeness, 10. Right? Frankenstein, nickname, Frank. Frank. Awesomeness, 9. Just a shade under. Right? So you kind of see if this was my database, I now have 2 rows in 3 columns in my people table. right? So just rows and columns. If I go back to my SQLECTRON, right, I want to look at some of these tables. I have all sorts of tables in here. I don't think I'm supposed to have customers in here. I think that's from a later thing. I don't know. So I'm going to look at what's one of the first ones, fruits. I must have messed with this database. I'm going to look at albums, right? So albums has 3 columns. Can I make this bigger? Can I zoom? Magnifier settings. Ooh, snap. Because that's really small. There you go. Cool. So I have albums, right? I have albums with album ID, which is an integer. I have title, which is an nvarchar 160, a Unicode character 160 in length, right? And an artist ID, which is also an integer, right? So I can kind of pretend that same type of thing in here. Like if I wanted to make a new worksheet and call it artists, I have a name, no, not an ID, I had an artist ID, a second one, I already forgot what the second one is. Title, this is albums, man. Albums, we have an album ID, zoom into this too. Right. Album ID, title, and artist ID. So album ID number 1 is beans, artist ID 1. Album number 2 is more beans, artist ID 1. Album ID 3 is please stop with the beans, sung by the same person. Right. So each row in my table, just kind of like these numbers on the side, should have a unique identifier. Typically, we make these with numbers to increment them. That way, I'll have always a unique way to reference this specific row. I say number 1, okay, it will always be this row. It won't ever be any other row, just this one. And I can use those to look up other tables. Look up artist ID number 1. Cool, right? I'm kind of referencing more than one table, which is pretty neat. Maybe I had an artist table in here and I could find out what number 1 was and kind of manually put this data together. But a gist of SQL is going to be rows and columns. Just rows and columns grouped in tables. Right? One of the trickier parts about SQL is the data types. Right? It only knows how to put a specific type of data in these columns. You're defining it that way. That's a lot more for protection and data storage than you'd imagine. If you define a column as an integer and you try to put a string or something weird in there, it's going to say, hey, this isn't a number, right? You shouldn't be doing this. You told me you only want a number, so stop it. Right? Let's look at some queries and we can kind of maybe see how this materializes. Right? So if I select star from albums, right? I want to select all of the columns, album ID, title, and artist ID, from albums table, from this table right here. I run this. There we go. If we run this, I get kind of that spreadsheet looking output, right? I get album ID, I get title, and I get artist ID. I get all of the unique album IDs, their titles, and their not necessarily unique artist ID, because an artist could sing more than one album, but I get all of this data out, right? This is all of the data in the table. And I can see that the album IDs are all numbers. The titles are all less than 160 characters. If I tried to put one in that was more than 160 characters long, it's going to give me an error message. Right? And an artist ID. So you may think too that why shouldn't I just make this title just like the biggest container possible for like an album? Why limit it to 160? Right? That kind of harkens back to data storage, right? consumer data storage is relatively cheap, right? Like enterprise or like server data storage is a bit more expensive. They're supposed to run long-term, have a lot more load on them 24/7, right? So you kind of think of what a normal price to put a hard drive in your computer would be, multiply that by a couple times, and you're going to be the equivalent like enterprise server hard drive storage, and at least that couple times, right? So if the storage gets more expensive, then the amount of data we're storing on that system starts to become important, right? In this table, there's 347 rows, right? And our database in total is, what is this? 866 kilobytes? Well, it's not too big, it's under a megabyte. But if this was 347 million rows, right? Add 6 more zeros onto the end. Does that mean that this would explode out to 866 gigabytes? Right? That'd be a pretty big database, right? And you think of like a 5 or 10 characters, give or take here or there, right? Because it's going to pre-allocate that space for us. So if that expands too much, the storage just explodes. It's a whole lot bigger real quick, right? So small scale length of data types isn't super important. It's still important to keep in consideration, but larger scale, these things start to be much more important. You start needing to look at your data much more fine-tuned and say, you know what? How long should a name be? How long should an address be? How long are postal codes and phone numbers? And you kind of stretch and scale these things to give a little bit of padding, right? But in most normal cases is what you want to do. Like how long should an email address be? Right? Do you want to give like 40, 50 characters for an email address? If we're trying to gather comments from a user, you think of Twitter, right? At some point, they probably expected they were getting such a volume of data, they need to store it and retrieve it quickly, right? So limiting to a certain character count was probably very smart on their part, right? It kept their storage down to a minimum. It kept their transmission down to a minimum because at most they're only sending around small bits of data at a time. If they accepted paragraphs of data in a tweet, did I say Twitter? I was thinking of Twitter. But if they accepted paragraphs, then you think that every time somebody wants to read a message, they got to get that whole paragraph back, like 30 times the storage space of what a normal one would be. Right? Which is pretty neat. Behind the scenes of SQL, there's a lot of stuff going on. Right? But in general, it's just storage of rows and columns named by a table name. Right? Which is pretty neat. So what else can we talk about with databases? So a SQL database could have as many tables as I want. I can kind of name them however I want, right? Typical naming structures for databases are for table names to be plural. They're collections of things, right? So that kind of means that albums contains album objects, right? An album is in albums. I can pull a singular item out of a plural list. Right? I can get an animal from animals. I can get an album from albums. I can get a fruit from fruits. I can get an invoice from invoices, right? Keeping these plural names makes it a lot easier to identify what's a multiple list and what's a singular item, right? So I could say, get the album where the ID is 5. That means I want to get a singular thing from the albums table, right? Select star from albums where album ID equals 5. There we go. I get a single one. So kind of the verbiage of how I want to describe getting this data out helps describe what I want to get out from where. I want to get an album where an ID is something from my table. My table name is plural. Right? So a lot of the word problems resolve around SQL kind of use this same kind of verbiage with singular and plural. Right? This kind of harkens back to arrays in other programming languages. Arrays are typically pluralized and singular items from them are singular. You can pull a single item from a list. Right? You can pull a book from a list of books. Right? Pretty neat. And kind of keeping that naming structure will make sure that you're consistent. Right? If you kind of had 50-50 where there was a table just called genre, think, well, there's just one thing in there. It's not a list of genres, it's just one genre. Right? One of the other important things about dealing with SQL is to save your information, save your queries. Right? I can't stress this enough. Save your queries. Right? As soon as I close SQLECTRON, any unsaved tabs are gone. So if I'm making a complex query, I'm going to go to File and Save Query. It's going to save it into the same folder you're at, and I can just give it a name. Right? Now we'll see that this shows up as a SQL file. Right? A SQL file isn't anything special. It's just a text file with a .SQL extension. I can open them up in text editors. Like I could open this up in Notepad, right? Anywhere that can read text, I'll see this information. I could open that up in Visual Studio Code, see what it looks like in there. All right, cool, same thing. Right? If I double click on it, what does that do? It's gonna ask me what I want to open it up with. Okay. So make sure to save your files, right? Save your queries, right? There's nothing worse than losing a large chunk of work, right? Kind of a pain. So then, what if I want to do more than one query on a page? As long as I'm ending my queries with a semicolon, I can write more than one. And I will get query 1 results and then query 2 results. That's going to make sure when I'm scrolling, I'm a little bit more careful, so I know which part I'm scrolling through. And as well, I can save this, and all of this content is now in my SQL file. Okay. So again, I can't stress it enough to save these files, especially when you need to try to submit your work or recall older work or give yourself some examples. Make yourself some templates. What does a create table look like? What does select and insert and delete and update statements look like? How do I drop a table? How do I make a view? Right? All these things you can make yourself your own examples and structures and templates and instructions. Right? Put some comments in your code. Right? Select all artists. Right? Give yourself some notes. I can't say how many times I've written code and looked back at it like a month later and gone like, I have no idea what I was thinking. At the time I was clever, but after the fact, I am nowhere near as clever as I was in the moment. Right? So give yourself some directions, especially if you had to do something that you had to figure out or reference from somewhere. If you had to look it up somewhere for some reason, you're like, you know what, this didn't quite work. I found an answer on this one website. No. Right? This isn't a real website. I'm going to go to this. Right? If Ammon is awesome as a website, then okay, Ammon is awesome is not a website, which is something that I probably need to go and register, because that would be awesome. Right? If anybody's watching this, don't register it. I will hunt you down. Anyway, but give yourself your own references. Right? Say where you found things. Say what lesson you found content from. Right? Say what hands-on you were working on. Right? Write your own documentation, your own stuff to look at. Because then, say maybe you didn't want to keep all these files around, print it out. Make a folder with all your queries in it. Right? Sometimes having something tangible on paper you can leaf through real quick. Right? Reference books are great. You can highlight and take notes and print stuff out. If you don't have access to a printer, save your queries. Stick them on a thumb drive or something, right? Make your own reference material, which is pretty handy. Cool. So SQLECTRON, databases, right? Some verbiage with these databases. A SQL database is a relational database, right? So, is that zoom in? Right. So SQL is a relational database. What is a relational database? A relational database means that tables have relationships. Right? We can see that. We can kind of see the side effects of that by a lot of these IDs. Right? I'm referencing an artist by an ID, and then my artists have an ID. Right? So this Chinook database actually has a diagram. It shows how these tables link to each other. Right? If you didn't know, the Chinook sample database is like the sample database created by SQLite to illustrate their database technology. Right? It's a pretty common and popular database. So then I'm going to pull this page up. I'm going to leave the address up here too, so that it gets recorded in here. Right? So here is the Chinook sample database diagram, right? And when I say that this is a relational database and these tables are interlinked with each other, here's the visual representation of that, right? So let's look at artists and albums, right? I can see that an album has an artist ID that is linked over to an artist ID on artists, right? What was the acronym for this thing? RDG, Relational Database Diagram, RDD. Can't remember, there's an acronym for this type of file. Can't remember off the top of my head. But as long as I can kind of trace a line from a table to a table, that means that a relationship exists and I can get to that data, right? That means I can go from artists to albums to tracks to invoice items to invoices to customers to employees. So I can see which employee sold to which company, which customer, which tracks from which album, from which artist, right? That's a strong amount of information as long as I'm capturing that data correctly in those tables and pulling it back out correctly and joining it correctly, right? One of the strengths of these systems is that I can add as many artists as I want. I can add as many albums as I want. And then later on, I can hook all of this data together as long as I use those relationships, right? When I want to make an invoice, it needs an invoice item. An invoice item needs a track. Track needs an album needs an artist. But if I work backwards through that chain, right, I don't need those things yet, right? I can have an artist without an album. I can have an album without tracks. I can have tracks without invoice items. I can have invoice items without an invoice, potentially, depending on the direction of that relationship, right? If you want to learn a lot more about these diagrams, what is the name for that? Yeah, there's a name for that type of diagram. Anyway, so this is a crow's foot diagram is what this type of relationship model is called. Crow's foot. Here's another example of it. Right? These little symbols actually mean things. Right? It's called crow's foot because of these three little guys right there. Right? That defines the type of relationship between this data. Okay. Shows that there is an artist. An artist can have many albums. An album can have many tracks. An invoice item could have many tracks. Track can mean many invoice items, right? These define the relationships. They're actually pretty cool. Some systems will make these for you as long as you set them up properly. So we'll also notice on this diagram that there are keys here, right? This key is typically the unique identifier for the row. It's called a primary key. And a primary key defines the unique identifier for the rows in the table, primary key, the primary piece of information that defines our data, right? We won't see it when we look at some of these definitions here. The columns don't necessarily say which ones are the primary keys, right? I thought there was a quick create table in here. And they're not a quick create table. But if I wanted to make a table, and this is a little bit later in some of the lessons, right? I can make a table with a primary key. I'm not going to write that quick, but I can make tables with primary keys and define what type of information goes in them. So that primary key is pretty important, right? You won't see it in here on these tables. Some other database engines might show them to you, right? So cool. There is that. I'm trying to think about anything else with SQL that would be helpful, right? The one thing SQL is not the best at is giving you error messages. Right? Sometimes it'll tell you, no such table of beans. What if I wanted to select asteroids from artists? No such column asteroids. Right? If I wanted to do more complex things, like star from artists, where name like B. Right. Oh. That actually was a thing. I was trying to make like an invalid query, right? No such column title. Or name greater than 50. Right? It's gonna look like it works. It's kind of weird, name greater than 50. Right? I'm actually trying to get it to do some other error messages, but those ones have actually been pretty straightforward. Do a comma somewhere. Yeah, this is a pretty common one, like an error near a symbol. Right? It doesn't really tell you. I wish it would tell you what line number these problems were on. This actually executes kind of as one big line, so it's not really going to tell you sometimes, and the editor isn't even going to really tell you. So kind of make sure when you're writing your queries, just write them a piece at a time. It'll go a long way. Right? Sometimes just look at the errors and see what they say. If there's a weird symbol somewhere, just look to see if you have that symbol. Maybe it's in the wrong spot. Maybe you meant to add something. And maybe using some keywords that aren't quite right. Error near and. All right, sure. Does it need something after it? Was it before it? You know, if you wanted to run more than one query. Now I forgot my semicolons. It's going to say there's an error near select. Well, unless I was a little bit familiar with this, I might have forgotten that I needed semicolons if I want multiple queries. Right? It's pretty much just trying to tell me though there's something wrong near one of my select statements. It's not telling me which one. Right? It just means that I missed a semicolon. If I run this again, it should execute. Right? So SQL is pretty fun. Right? It's been around for a long time. It's a tried and true and tested system. Right? It's great for separating concerns of data. Right? You can manage just individual tables at a time. You have the strength of combining them into many complex ways. Right? And if there's a couple key things I could leave you with, make sure you're opening up the DB file and not the zip file. Right? Save your work, save your SQL files, save all of the hard work you've done so far. Right? If you haven't done it yet, start doing it. Right? Make your own reference. I wish I could tell you that I could remember all code off the top of my head. I look up stuff all the time. And a lot of that is my own reference and my own sample projects, right? Even now doing this stuff, I've done a lot of code ahead of time that I look up for my own reference. Right? I don't have an eidetic absolute memory of these things. I don't think anybody does. Nobody can really go down and just write reams and reams of stuff from scratch. Usually there's a lot of preparation that comes ahead of that, right? I see a lot of presentations where people are doing all sorts of code like crazy. They may very well be doing that off the top of their head, but they've probably prepared a little bit and done it a couple times ahead of time, right? Especially with our lessons and our content, there is no expectation that you're memorizing all of this stuff. When you're working on hands-on assignments, look back to the couple lessons before, right? We're usually trying to lead you to a certain direction and use your own reference from just the content material, the other queries that you've written, right? Copy and paste some parts from your other queries. Like, use work you've already done, right? One of the great things about computers and technology is that you can do that. You can reuse your own work, right? So cool. Before I lose my voice completely, because it is kind of slowly going, I've been having some cough drops and some coffee to see if I can alleviate that. But pretty much just a basic on SQL and SQLECTRON, right? Some tips and tricks, some things to watch out for, maybe some positive things to do, some hiccups you might have. And yeah, have fun with SQL. It's a fun language to learn and very valuable. So cool. I will see everybody after the holiday. Everybody have a great Christmas. I have some exciting stuff for after the new year, right? You can do some different types of workshops. It's going to be pretty cool. So, all right, I'll get this uploaded to our database album and channel as soon as I get access to the video, and I will see everybody later.